We are now in the logs unit. From the worksheet you just completed, you should be able to see a connection between logs and exponential functions. The connection is that a log is the inverse of an exponential and vice versa. Given an exponential function y equals b to the x, the inverse of this exponential is y equals log base b of x. A big part of the log function is being able to be given an exponential function and write it as a log function. So it's really important to notice that this is b, our base of our exponent, and this b is the base in our log. This value, when we rewrite and going back and forth from log and exponential, is always the same. So the base of the exponent is the base in the log. If you were given the exponential function 5 to the third equals 125, the log of this exponential function would be log base 5 of 125 equals 3. Like I said before, notice the base 5 in the exponent is the same base in our log. An easy way to remember how to go from an exponential to a log, other than just memorizing the orders, I call this the popcorn method. So if you start at your base 5 and you go log base 5 of 125 equals 3. And if you notice, the yellow line I just drew kind of looks like a popcorn puff. So again, we would start log base 5 of 125 equals 3. One more time, that's log base 5 of 125 equals 3. The same popcorn method could be used if I give you a log function and I ask you to write it as an exponential. So we're going to start with 5, our base, and say 5 to the third equals 125. So that was 5 to the third equals 125. And one more time, we start with our base 5 to the third equals 125. And again, the red and yellow lines look like a popcorn puff to me, so that's why we can call it the popcorn method. Alright, so here are a couple more examples to help with this converting back from exponential to log function. We know that 10 to the second is 100. So this means that the inverse of this as a log function is going to be log base 10 of 100 equals 2. Next example, 10 to the 0 equals 1. The log function is going to be log base 10 of 1 equals 0. 2 to the third equals 8. Log base 2 of 8 equals 3. Okay, so if we did the popcorn method, using the exponential side, I'm going to rewrite it with showing you the popcorn method so you can follow along in the red, the log form side. So we start with 10 log base 10 of 100 equals 2. Log base 10 of 1 equals 0. Log base 2 of 8 equals 3. Okay, now going from log function to exponential, log base 3 of 5 is 3 Okay, I'm going to start this one over because I need to put in what log base 3 of 5 equals. I apologize for that. Alright, so we're going to do log base 3 of 5 equals 1.5. Alright, so our exponential function is going to be 3 to the 1.5 equals 5. Log base 2 of 16 equals 4. Two to the 4th equals 16. And our last example, log base 8 of 8 equals 1. And the exponential version is going to be 8 to the 1 equals 8. And again, that popcorn method, you would start log base 8 of 1 equals 8. 2 to the 4th equals 16. The base 3 to 1.5 equals 5. Okay, so this is really important to know with logarithms. The standard logarithm, it has a base of 10. Any other base is going to make us use the change of base formula. Now, we're not going to use change of base for a while, so it's really important to know that logs have a standard base of 10, which is what you notice in the worksheet you did prior to this. So what this means is if I ask you, okay, tell me what is the log of 2? What does that equal? You can use your calculator, and it's the button. It says LOG. It's right next to 7. It's on the very far left-hand column on your calculator. So this is essentially saying log base 10 of 2. So I can evaluate this in my calculator, and I'm doing it right now. Log of 2 equals, so your 0.30103 if we rounded that last one. So in your calculator, you can't put any other base in, just 10. So that's why if you don't see anything right here in this base position, it's understood to be 10. And then if you're going to use a calculator, you can only use and evaluate logs if they have a base of 10. And this is until we do the change of base formula, which we will eventually.